Hello, my name is. I'm CTO of Ponos Technology. I'm coming from hardware world. We heard a lot about race to zero and so on. So I'm coming from design of such a hardware and design of cryptographic primitives in hardware. And yeah, I'm have a PhD in microelectronics. Worked for many years in IBM research before I actually jumped into blockchain world, particularly into ZK. And yeah, I'm with Ponos for the last 3 years, and now we are also partnering with Telos and doing a lot of interesting stuff, as you had a chance to hear in the previous presentation.
Awesome. Yep, go ahead. I'm QEDK. I'm a senior R&D engineer at Avail. I've been in Web3 for 4 years-ish now, but I mean, that's kind of when I graduated, so it's been really happening. So nice to have someone like Milos here on this panel, to be honest. Prior to this, I was with Polygon, where I was working on Solidity team and also writing protocol contracts in the core protocol team. So that's kind of it for me.
And I'm Jesse. My background was about a decade of enterprise software, about half of which was at ServiceNow. I rode that from a 100-person company through 5,000 through the IPO, and learned from a lot of really smart people there how to build software at scale and deploy it in the cloud. And then also how to build a platform that people could use to build their business applications and solve the big business problems. Got to spend a year there working with enterprises like Morgan Stanley and NASA and all sorts of incredible learning experiences about how business is run. And then in 2018, along with JT and over 100 people, we all put together Telos, launched it decentralized without an ICO, and been riding that ever since. Helped build our EVM about 2.5 years ago, and that took us even further into where we are now, and came on full-time into Web3 about the same time as we launched the EVM, and here we are.
Very good. Thank you, guys. Nice to have you here. All right, we've got just a little popcorn style. We've got 4 or 5 questions that we're going to ask the panel. They have had the questions in advance, so hopefully it goes pretty quick, right? So as most of us are aware, ZK proofs are fairly computationally expensive. So what advancements are being made to improve the efficiency and performance of ZK proofs? And what are some of the bottlenecks that we still need to tackle? Milos, you want to go first?
Right, sure. Yeah, they're still very computationally intensive. And, well, there are a lot of things that great progress has been made in the last 3-4 years, particularly in the field. Now I'm going to kind of go a little bit, sound a little bit subjective in the field of so-called start-based proofs compared to snark-based proofs, where kind of we're getting more and more efficient fields. And as is what mentioned at some point, basically start-based proofs, they don't need a ceremony. They kind of don't need to get certified, and they have some advantages. For example, that they can be crypto secure, and one thing is they can work with almost arbitrarily small fields. And going into smaller fields brings a lot of advantages in the computing the proofs faster, using less resources and so on, and opens up possibilities. And we see typically that the size of the fields was 381, 382 bits, then going down to 254 bits equivalent. Then we went to Goldilocks field with clunky 64 bits. Now they're 31-bit fields like Baby Bear and Mersenne 31. So we are finding, at least in the side of crypto primitives, more and more efficient ways to do it. And they're also more and more efficient ways to compute things which are already known. For example, for like MSMs in Snark Pros, there has been like a big breakthrough recently in a way how they can be computed and a lot of gain both in like server side and like on the client side. Like for example, was improver recently, like in Z price, has been like accelerated almost 1,000 times from the previous state of the art. So like giant leaps have been made to kind of make things faster and more cost effective. I mean, the proving.
Yeah, I kind of echo what Milos said there. I think another exciting area has been proof aggregation. I think RISC kind of presented a very interesting side on like how they have kind of advanced state of the art in terms of ZKVM. So like I think we're going to see more interesting constructs like such as ZKVM and ZKEDM and ZKVM. I think Kakarot is doing something like that on using on Cairo VM. So that's like been very interesting to see. I feel there's also Snarktor, of course. They're kind of trying to advance the same sort of technologies, and that's sort of the same utility that we kind of need in our interoperability, like Avail Nexus, right? So we feel like there's a really good spate of technologies that have been developing in the past. I mean, and also like you mentioned, reducing the sort of the number fields. So I think Polygon and Stark were kind of recently also worked on circuit starks to kind of advance that. Further, like I'm not smart enough to understand the paper, sadly, but so like I've spoken to some of the Starkware folks, and it's like a very exciting primitive that they've introduced. So that's kind of what I've been observing with the past couple of months outside.
Yeah, I think that kind of like Milo said, there's been advancements with all the different proving types, and I think in trusted setups and things like this, where we're starting to realize that there's just certain things that work in certain cases and certain things that don't work in certain cases. And as you get the right tool for the right job and you apply that, you can just really start to tune in how you're designing a ZK system. Whereas maybe in the early days, it was just, we're doing a proof and we've actually done zero knowledge. No, it's actually what's the right one for the right purpose, on-chain verification, optimized for verification versus proving, things like that. So as the more options you have, the more you're able to optimize just from a more of like a design and architecture perspective. And then of course going into, getting all the juice out of it that you can with hardware and everything else. So
yeah, awesome. All right. So given the great number of layer one blockchains that we have in the competitive space, what do you guys feel like ZK is really going to do to bring us all together and achieve some of the challenges as far as scalability is concerned, and bringing us all into one operable chain, so to speak?
I think if we look at the state of chains today, the fact is that ZK rollups have sort of already taken that spot, like where they are the de facto scaling layer for Ethereum, and that's pretty cool. I mean, that's kind of exactly what allows us to use something like recursive proofs and solve the problem of liquidity fragmentation, UX fragmentation. That's kind of the benefits that we get from actually using ZK in those particular scaling solutions that you wouldn't get at all on like optimistic solutions where your guarantees have to be cryptoeconomic primarily instead of cryptographic. So that's kind of like I expanded on Avail Nexus in my previous answer, but I think that's kind of another thing that I want to throw in there as well, is that by having ZK rollups, you can kind of develop these adapters, like I think RISC kind of mentioned them as well. These adapters can kind of convert the STF or rather treat the STF in a certain form. And then with the order guarantees in the DA itself, you can kind of have that unification layer experience like for all the users of crypto, where they don't need to really worry about where their assets are going. It just kind of just works.
Yeah, exactly. If we can reach that point, I think we all have a dream of interoperability without users having to feel the interoperabilities. And at this point, I think we're probably a lot of us here at this event, we now get to know that it's possible. We now know that the ways that we're going to get to that point are within our means. We may not be there, in a year, but at some point we're going to get there, and we're going to get there with zero knowledge. It's going to help all the interoperability, and it's going to help it in a trustless way where we're not relying on multi-sig and things of that nature. So it's just exciting to know that like the ingredients are starting to become available, and here sometime in the next maybe a couple of years we'll be there where retail mass adoption can come in and never need to know even if there's a blockchain or which one it's on, and worry about the elements of trust that they have to decide which network is the most secure and things like that.
All right. Awesome. Welcome, sir. I'd like you take 20 seconds to introduce yourself. Hey, sorry I'm late, everybody. Scheduling conflict from this act. I'm Brett Carter, a lead product at RISC Zero. RISC Zero has built the first general purpose ZKVM. That doesn't make much sense to you. Hopefully I'll be able to describe that in a little bit more detail through some of these questions. But the TLDR is we make zero-knowledge cryptography really accessible to regular developers. You don't write arithmetic circuits. You don't have to code sort of the math equations like you do normally in basic proof systems. We created an abstraction layer on top of our proof system so developers can just write Rust and Rust programs that inherit the characteristics of ZK. And so, Telos is actually using our proof system to do some cool stuff. So that's me.
Awesome. Well, since you're new to the panel, you can also answer this question first. So, what are the most promising techniques or protocols that you see currently being developed to leverage ZK proofs for these scaling purposes?
Techniques or protocols. So there's a super broad range. First that comes to mind, it's a Telos ZK, so I might as well show Telos, right? But really, Telos is doing a really neat thing. If you think about the barriers to adoption for DK, which were being discussed, it sounded like we're being discussed as I was walking in. One of the downsides of ZK is it's been quite slow and expensive to generate the proofs. And you can think of the cost of ZK in two parts. There's the proof generation costs, the proving cost, and then there's also the on-chain verification costs. And so there's been lots of progress made on the proving cost side. Our prover, for example, is like roughly 100x faster than it was this time last year. Or at least we're 100x better at proving Ethereum blocks, for example. But still, there hasn't been much ground made on improving the verification costs for ZK. And so solutions like Telos and other aggregators and the ability to basically take all of these proofs and merge them together in a single proof and then verify them all at once is very, very promising in the technology.
Yeah, I think the obvious one is like a ZK EVM, right? Scaling the blockchain by moving it to a layer 2. And we've seen layer 3s, horizontal scaling of blockchain and verifying them all with zero-knowledge proofs is an obvious scaling approach. But one thing that I think that I've thought of before, if you think about use cases like gaming and just moving the entire logic of something that's pretty complicated off-chain inside of a ZKVM, where now maybe a game developer now has access to implementing their logic off-chain and not actually needing to do it all on-chain. So you can actually scale the blockchain, not just by having more blockchains proving off-chain in the layer 2 model, but actually having parts of what would normally have to be in a smart contract be actually executed offline. There's probably gaming's, a good example, but there's probably a lot of places where something that you wouldn't complete in a smart contract transaction now can be done off-chain and then verified on chain.
I got a plus one that right quickly. Just add something, which is we've been focused on scaling in one way in blockchains, which is like the trade-offs that fast blockchains make. They're on the limits of your execution, like how much compute can you do in an individual transaction or an individual block. If you set those limits lower, right, you have smaller transactions, you can do them faster. And then the other sort of way that the blockchains and scaling is like you also require bigger machines so that they run that computation faster. So you can think of the contrast between Ethereum and Solana as like Ethereum with bigger machines and smaller transactions is like how they made it go faster. But there's still limits, right? There's a hard transaction limits, hard block size limits. And really ZK lets you unbound those parameters where you can do unlimited execution off-chain. Like for example, you can literally run AI inference under ZKVM today and verify proof with that on-chain. And so we like to think that it's like boundless scaling, removing those inherent limitations. So really this enables blockchains to scale in a new way that wasn't possible before. And, we have a solution called Steel, for example, that lets Ethereum developers do this, just writing Solidity. They don't, you write a little bit of Rust and you can literally call your existing functions that live on the blockchain. You can call them off-chain for free. almost for free, essentially, just for the proving costs.
And maybe another interesting approach we see, like from Starkware, we see also from Polygon, where instead of like executing or generating the full proof, it's broken into like subproofs or into chunks of the trace. So you have like a proof decomposition. These can be generated, the subproofs in a limited time, much shorter time, and then they are recursively aggregated, composed back together. So proof composability, and this actually kind of is one of the major obstacles to get proof generation directly in the time for Ethereum to be like under 12 seconds, which previously was not possible, particularly in case of like ZK VMs or ZK EVMs, where like a typical proof generation time would be in minutes.
I was going to talk about like the developer experience of working with ZK. Like that is kind of a hidden cost that we kind of don't consider when we build ZK at all, right? Like a lot of the previous work has been like how to kind of do it with R1CS constraints. Like I think RISC kind of furthered that by, like right solidity just works. Right Rust, it just works sort of a paradigm, which is interesting because that's sort of the developers that I sort of think that we need now. On the hardware acquisition side of things, I think there's of course Ponos, there's Portaway using FPGAs, there's Ingonyama. I think they have ASICs where they use GPUs to kind of achieve that same purpose, where there are MSMs and they're kind of batched MSMs as well. That's another interesting way that kind of to speed up the ZK runtime pipeline, so to say. So that's kind of the thing that I was thinking about.
All right, so my next question was kind of covered in the previous presentations and really in your most recent answers. So, as far as hardware acceleration is concerned, where do you guys see hardware acceleration going? Are we always going to need it?
Yeah, I think we're going to need it more and more. And it's kind of a natural process if you look like how it was with mining. Like in the very beginning, it was done only like on CPUs and then on GPUs, then on FPGAs. Then like first dedicated ASICs came, and now like for quite a few years we have like a really big mining systems which are purely like custom designed to be the fastest and most efficient possible. The same roads will naturally happen with like acceleration for ZK proving, and we see this already, like these very same steps already repeating in a sense. So first we had it like almost exclusively on CPUs. There is a lot of work on GPUs. There is now work on FPGAs. There is also work that's been done and coming soon, like on first ASICs, both in like in MSM or the work like the Fabric is doing. So and there will be more and more, and eventually we'll end up with kind of really dedicated hardware on ASICs that is exclusively used. Like if you want the cost performance solution, yeah, you would have to use the custom accelerator.
Yeah, I'm just going to echo what Milos said. I think like we're seeing really good solutions with acceleration GPUs and FPGA, but the eventual end game will be like where we have like proper ASICs built for ZKVM proofs. That's going to be like the ideal solution probably a couple of years down the line.
You still feel that way, even if it can't be updated?
It definitely, I think the question comes from like how secure your cryptographic system can be. So like all of the standards that we're using today, it has to be battle tested to some degree. I feel that's kind of the wide prevalence of ZK rollups today will give us where like a lot of these systems will get formally verified, which is a lot of the architectures as well.
Yeah, hardware is definitely a really important part of the picture. I can't imagine like our fastest prover is our CUDA prover right now on NVIDIA GPUs. I would be really sad if we only had a CPU prover because things go a lot slower on the CPU. I think it's interesting though, because like you can think of this in terms of, traditional computer, non-verifiable compute, right? Like computers get faster and faster when we find new things to do with them, with all that additional compute capacity. We're pretty creative individuals, people or human beings are a pretty creative species. And so you think of like, we invented this thing called, AI ML. We have these huge, large language models to train, and there's not enough computers in the world to do all of that, right? And so we sort of continue to find new use cases to sort of zap up that additional compute resources. And so, I think hardware acceleration will continue to remain an important picture. But the faster we get things to go, the more use cases we're going to enable, which is really, really exciting. One other note that's like maybe a little counterintuitive, or the other side of this question, is the faster we get the provers to go, the more of the proving we can also do client side, which I think is a really exciting area to consider as well. We're really excited to get our small proofs, basic signature checks and things like that working in the browser. Maybe even now we have to rely on some hardware even in those environments. Like we have a metal accelerator, for example, that accelerates on iOS devices or on MacBooks as well. And we're planning to work on like a web GPU HAL for our prover so that we can get some web GPU acceleration in the browser environment as well. That unlocks a whole new set of privacy use cases and just sort of further innovation as well.
Yeah, I was going to say that I'm really curious to see where we go, because obviously hardware acceleration on, more non-private use cases like scaling group aggregation and scaling ZK EVM proofs is clearly there's demand for that. But ZK also is an important part of privacy, which then links back to what you're talking about, client-side proving and how a user can protect their data. And they may not have access to FPGAs and ASICs. So I'm just curious to see where, all the brilliant minds working on ZK take that for a solution. Like, how do they start solving for client-side proving and actually doing it efficiently and really bringing in that last mile of users that we're going for, the retail users, everybody outside, this restaurant.
All right.
Yeah, let me just add that this, it's kind of a vision that, and this is just a couple of years ago, and quite a few people actually had this, that eventually there will be like a USB, like Bluetooth device, which is very slowly, you can have the key attached to your device, and that will be able to provide necessary hardware acceleration if your device doesn't have like a sufficient computing power, to do it by.
Yeah, there's so many people this week that walk around with their phone plugged into the battery charger, right? But it could just be, their hardware accelerator, so they can be doing privacy on the go, right?
That's good. All right. So everybody talks about all of the privacy guarantees and all of the security, but as far as downfalls are concerned, like what are some of the potential vulnerabilities associated with the implementation of ZK, especially hardware accelerated? And what can developers do to mitigate some of those risks while ensuring robust deployments? Anybody?
Yeah, okay, I can take that. I think definitely, I was mentioning this a lot, the other answer I was kind of giving, is that formal verification will become very necessary, actually, for a lot of these systems. The problem, of course, is that today we have so many cryptographic systems, so then we kind of need to pick and choose, what is actually valid tested, which proof system is actually sound. And of course, secondly, what this kind of also translates to is that your circuits, whichever the language they're written in, whether it be constraints, whether it be like Circa, whether it be Rust, even that needs to be audited quite properly. And I don't think we're at this stage where a lot of teams are well poised to audit such code. A Web2 security companies typically will not take this on, because it's like a new paradigm that kind of they have not been preparing for, but which means the space will be very competitive and expensive. But I feel probably a couple of years down the line, definitely much better. But I think I see that to be a very big challenge, especially in terms of just beginning the KVM development, so to say.
Yeah, I'll add to that same sentiment, which is there's a lot of code risk, right? That's really what it is. There's a whole lot of new code, new crypto primitives. And how do you make something how do you make sure something's cryptographically secure? Almost verification is one way to do that. Potentially a lot of these systems could be formally verified. It's quite a complex process, and Ethereum Foundation, for example, is very interested in that. But it seems like plans to spend tens of millions of dollars to sort of help achieve that. We seem quite far off from systems who are sort of worth that investment, or maybe at least we're getting closer. So lots of code risks, and just using a hash function as an example, there's hash functions we don't use today because like broken, right? Like we thought they were secure, and they no longer are. It's like anybody using SHA-1 out here, for example. And so there's lots of that code risks. And so how do we mitigate that? Like we have to be very responsible, thorough audits, lots of testing, but really time. Like it does take time. Just like smart contracts broke all the time when Ethereum became real, right? The DAO hack, good practice around writing secure solidity didn't exist. We had to sort of invent that, and we had to get there, and we're kind of at a similar timeline in ZK. There's potential for soundness bugs, which soundness would mean you could just generate a false proof that is verifiable. And just as an example of that, in our steel library, the great part about general purpose ZKVM is you just write regular code, but there is a little bit of a downside to that, because if you generate like a dependency tree of this steel library, there's over 100 files in steel. That's a lot of code to audit. Thankfully, it's just auditing regular software. You're not auditing arithmetic circuits in that capacity. But so there's just all new practice. We need time, and there's not. It takes 9 months to make a baby. It's going to be kind of hard to accelerate time for that to happen.
Yeah, I think that there's it's not so much like what the risk is, but it's the solution. Kind of even take it one step further, and standards. I think one thing I've observed, kind of got into the space in 2017, and it feels like projects are becoming more collaborative and working together, maybe more than some of the earlier years where they were highly competitive. And with that, hopefully competitive standards. And if everybody is having a different, proving algorithm and a different approach towards things, and they kind of adopt a single or just a couple systems, then those systems can be more battle tested by more teams and more projects, and with more usage comes more opportunities to find and fix issues.
Just realizing that 3 of the 4 companies represented by the panel all use risk 0. So maybe we're working towards the standard, risk 5 at least.
Absolutely.
Yeah, and when I mentioned cryptographic primitives, there is like a whole world of established practices in basically in cryptography and applied cryptography, like in secure systems and so on. And definitely one thing that should follow in the community would be to take this good practices from the security space, meaning have security audits. For example, hash functions are a good example. They are in a way of in the security space. This gets audited and it get battle tested for decades before people come and claim that they're now like secure and so on. And we have so many variants, we have so many flavors, so many small changes. Yes, they have a good they come from the good ground. They're sound. They're tested from the kind of basic way of all the attacks and so on. But they definitely need kind of more scrutiny from like a community that has expertise in security auditing and in cryptographic testing and so on. So this is one piece that's like applied community, as basically the whole ZK space is kind of just took it for granted without too much getting into those kind of well-established practices in the security. So we should also kind of try to go more into that direction.
Okay, awesome. Well, that's it for the main questions, but I want to give you guys opportunity for final thoughts. So bonus question is, what do you guys think that we'll be talking about here in 5 years? Start with Jesse.
All right. So the surprise question. Nice. I think that we're going to be talking about in 5 years, which on blockchain is about 15 to 20 because it moves so fast. I think we're going to be looking back on like how we got to where we will be. But I think by then we're going to now hopefully observe the mass adoption of of blockchain and decentralization with the catalyst of zero knowledge. I think it's really what can enable the users out there to not have to put as much trust in the counterparty, which will become hopefully the large businesses that can eliminate risks by using zero knowledge. So between the two sides and, ZK and cryptography, as well as blockchain, because blockchain then becomes more of an option if there's less trust involved. I hope 5 years from now, we'll be able to look back and talk about like the evolution and really where things really started at, these hockey stick inflection points, and everybody started to do this, whether it's the hardware or other things that really, start to open up the doors.
Brett, so 5 years from now, we're all going to have Neuralink chips in our head. You're watching this conference, generating verifiable inference proofs that we're at this top. If Eli has this way. No, we probably won't be there in 5 years. But yeah, I think I love that sentiment. Like this ZK helps blockchain, decentralized infrastructure. It will make it palatable for organizations like the rest of the business in the world that, haven't come on chain. And I think there's a primary reason why. So this is like, I guess my prediction in 5 years is that we will have adopted privacy solutions that allow individuals to have sovereignty over their data. So like, how it's hard for a business to come on chain. You publish your ledger, your balance sheet, your secrets, your advantages, we really need privacy in order for individuals and businesses to come on chain. And I would say a particular kind of privacy, I'll call it programmable privacy, which is, the ability to configure which information is revealed and which information isn't. Clearly, we can't have like sort of absolute privacy. Something like Zcash, is as great of a project as it is, like it's not likely to sort of take off and reach mass adoption, but something that allows you, for example, to reveal that you're over a certain age without revealing what that age is, for example, or reveal you have a certain credit score without over a certain threshold without revealing their exact score. I'm really looking forward to those types of solutions. Awesome. Before we get to you, I'm sorry, you guys make sure to tell people how they can follow you on social.
I'm Foflexity, FOFLEXI2Y on X and Telegram.
I'm not going to try to tell you what my Twitter handle is, so if you just search my name with a space, Brett, space Tartar, I think I'm up there. You should see there's no cartoons or anything. You can see my actual face.
Same, but it's a pixelated version.
Awesome. QEDK.
Yeah, so instead of maybe where we will be, maybe I can talk about where I think we should be. Like I definitely, as Brett said, like I want to be in a place where we are kind of discussing the privacy use cases of ZK more, because kind of the way it has worked till now is that ZK started as a privacy preserving tool. Now it has become a scaling tool, and like we're doing really well to accelerate that part of it, and that's great. But I feel we are kind of poised or in a good position where we can kind of give at least some of the control back to the users. Like kind of we saw Aztec come and go. I think they're going to do a V2 soon. So I mean, pretty cool. Nocturne, they kind of just left the space. So like Ethereum doesn't really have someone in that space, at least not a big competitor for now. I know there are a couple of startups definitely working in stealth, but that's definitely where I would want to kind of see the community move towards in 5 years, where using sub solutions is the de facto standard.
What about your socials?
Sorry about that. QEDK_ on Twitter.
Milos.
Yeah, so I think we can expect that the real decentralization is going to happen, and there will be really a lot of players that will be actually doing proof generation, verification, client side. Also, this will drive the cost generally down and help massive adoption. And also, in addition to having driving the cost down, having decentralization, I think in some way kind of either unification or will happen. So there will be kind of less well-established kind of standards, less players, but more dominant players. which would help eventually like interoperability. That will be very easy to go from chain to chain. That will be also cheap to go, like from chain to chain. Not only exchanges, but seamlessly, basically going from one to another without kind of having all these technical, but also like cost obstacles that we have at the moment.
Yeah, we better fix that over street. Great.
And for my social, so it's like Milos SH, so STMILOS, both Twitter and Telegram.
All right, perfect. Let's hear it for the panel.